All right, lesson 8.1 is inverse and joint variations. And what we're going to do in this lesson, our objective is that we're going to write and use inverse and joint variation models. Okay, so the objective today is to write and use inverse and joint variation models. So as a before we get started, I wanted to do a quick review on what direct variation was. And if you remember back from Unit 2, direct variation was when y equals kx. In other words, if you take x times some value, it's going to give you y. So in other words, if we're looking at this one, it says write an equation that relates the variables if x equals y very directly and x equals -3 when y equals -6. So in other words, -3 times what number will give you -6. And you find that that is 2. And that number actually ends up being k. So your equation is going to look like -6 equals -3 times some number. Okay? All right, so a couple of things when we're actually going to use this is to think about, okay, a couple of things I want you to consider is the relationship between the number of people helping to build a new house for a community and the number of hours it takes to build a house. Assume that the people all work 8 hours per day and have comparable skills. So on number one, if the number of people increases, what should happen to the amount of time? So if you think about it, okay, if you're building a house, everybody's got comparable skills, everybody works 8 hours. Well, if you get more people involved, then the amount of time to actually build a house should decrease. Okay? And if you look at example number B, the same thing happens. The number of people now decreases. So instead of but they're still working 8 hours, comparable skills, well then naturally that house is going to take longer because you've got less people doing it. So as one increases, the other one is going to decrease. Okay, and if the job deadline is pushed up, what can be done to help make sure the job's on time? Well, you've got to increase the number of times. So something's going to have to increase because of your time. And this is inverse variation. Okay, so inverse variation, direct variation is when one goes up, the next one goes up. In inverse variation, if one goes up, the other one has to go down. Okay. So in inverse variation, all we're going to do is now it becomes y equals that variable k divided by whatever your x value is. Okay. So let's go ahead and take a look at example number 1. In example number 1, the variables x and y vary inversely, and y equals 2 when x equals 3. Okay. This part right here is really not needed at this point. We just need to find what our k value is. So k equals x. So right now, if y equals 2 and x equals 3, well, what is our k value? Well, all you have to do is multiply both sides by 3, and you solve it. So k equals 6. Okay? But the real question is, we've got to find y if x equals -2. So y is our unknown variable. K we know is 6, and if x is -2. So y equals 6 divided by 2 is going to give us a -3. Okay. All right, so let's go ahead and take a look at another example. You can have decimals and fractions in this. So the find part that we're looking for is y equals, or find y when x equals 3. But remember, before we can even do that, we have to start off and find out, well, what is that constant that I've got to divide my x by? So if y is 6, k is what I'm looking for, and x is 1.5. So I multiply by 1.5. So I get 6 times 1.5 gives me 9. So I know my k is 9. So then, now I got to find my new y if k is 9 when x is 3. So you find out that y is 3. Okay? All right. The next example is joint variation, and this is actually when you're going to have 3 variables involved. Okay. So a joint variation would be z equals k times x times y. Okay, so it's a lot like direct variation. Z equals k times x times y. So let's go ahead and take a look at example of this. So remember our formula is y equals k x y z. Okay. Now, this is what we're actually looking for. What is z when x equals -4 and y is -7. So but before we can even start on to that, we need to find out what is our k. So if z is 6, we're looking for k, x is 3, y is 8, and z is 6. Okay? So I have to multiply. Ooh, wait a minute. No z in there. Sorry. So y or z equals kxy. So z is 6. We're looking for k. X is 3 and y is 8. So I get 6 equals k times 24. Divide by 24. And I simplify and I find out that my k is 1/24. Okay. So I'm looking for z again. So z is my unknown variable. K is 1/24. X is -4. And z is 7. Well, these will cancel. So I find out that my z is going to be 7/6. Okay. All right. So that concludes joint variation. Go ahead and try some of the practice problems. And if you have questions, my phone number is posted on Angel.